Hello coders. In this video, we will see what are pointers in Go, how they can be used, how they are declared and initialized, and what is the use case that we need pointers in Go. Let's get started. We'll start by creating a file, pointers.go. We will have our main package and main function and our formatting library. Now, let's say you want to declare a variable 10, which is translated into where x int is equal to 10. Now, what happens actually in the memory is that there'll be a block for x reserved where x will point to your value. You will have 10 and this will have an address 001F. Now, this address is randomly taken. The actual address may vary. So, this is how it is represented in memory. There will be 10 values stored for your x variable, which will store the value 10. Now, when a pointer is introduced, right, just like the name suggests, pointer points to an address in memory space, or let's say a pointer points to another variable. Now, what do I mean by that is, let's say I declare a pointer y. Now, how do we represent a pointer is using the star operator or the dereferencing operator. Now, where by star int, that means I will be storing an integer pointer. Y will point to a integer variable. That's what it means, equal to x. Now, if we write this, x is not actually a pointer. X is a value which is 10. To know that y is pointing to a variable x, x has to give its address. And what is the address we have here? That is 0x000001f. That's the address we have. Now, for us to point y to x is, we have to use an operator called ampersand. Now, this is the referential operator in Go, where y star int equal to ampersand x means y is an integer pointer that is pointing to x. Right now, how this is represented in memory is, we will have another block for y, which will have the address that is 0x1f, and this will have its own address 0x maybe 11111f, something like this, and y is holding a reference to x. Now, let's try and print the values for x and y. Println x and println y. Let's see the output. Go run pointers. You see the value of x is 10 and we have an address in memory space that is stored for x. The concept of pointers is that since it is pointing, one variable is pointing to another, if I modify y, the same modification applies to x as well. What do I mean by that is, let's say I will modify y by 5. When I directly access y, right, I am trying to access the address that's mentioned here. So we cannot directly increment anything. Let's say I try to do y equal to y plus 1, right? Now in this case, it will fail because that's actually pointing to a memory. To actually increment the value of y, what we have to do is we have to use star y. Now star y here means dereferential operator, means whatever y is pointing to, I want that star y is basically equal to x, right? Now if I do star y, let's try and print star y first. Star y, let's see what happens. Now in this case, you see x and y both are 10, but y we had to access using star. Let's say I modify y now, or let's say I try to modify x. After printing, I'll modify it as 15. Let's see what happens. You see x is 10. After modification, I'm printing y, but that is 15. But I modified x. That's because y is internally pointing to x. Now let's say I increment y the other way around. Now to increment y, I have to use star y to dereference the value, and let's say I'll assign a random value 20, right? And I'll print the value of x. I'll print it like this so that it's more clear. X. Let's see what the output is. You see x has been modified to 20, right? So whatever modification is happening to star y will always propagate here, right? Y will be our pointer to x and star y will actually hold the value. That's how pointers work in Go. Now, even pointers are tightly coupled with types. What do I mean by that is, here in this example, we have taken integer pointers and integer variables. Let's say I define a string variable. I'll take it John. And I try to reference the string variable to y. Let's see what happens in this case. You see there is an error. Okay, this is a not used error. Remove that and I'll run it again. Okay, this is again not used. Let's say I'll print it y, right? So that everything is used. Now I'll run this again. If you see what happens here is cannot use ampersand string value of type string as star int value in variable declaration. That is because integer pointer can only point to integer variables. Here our pointer is an integer pointer, but this variable that we are pointing to is of type string, because this translates to var str string equal to John, right? So types are also concerned or connected in pointers as well. Now let's see what is the use of pointers in Go. Now let's say we have a function multiply by 2, right? And it will take an integer input and it will not return anything. What we'll do is we'll directly try and modify the value here itself, a into 2. And let's say we have defined x equal to 10 and we call the function multiply by 2 and pass x. Yeah, in one of my previous videos, I had mentioned that the x that you pass here is the actual parameter and the a that we have here is the formal parameter, right? Formal parameter in the sense it is just a placeholder to hold your value of x. Okay, now let's try and print this out. Println x. Now, based on the logic, right, it seems that we have a here, a is multiplied by 2, and when we are trying to print x, it should be multiplied by 2. Let's try and run it. The value stays 10. It is not modified. Actually, what's happening here is when we have x which has value 10 and which has some memory, right? When we call a function that is multiply by 2 and we have a, right? There is an exact copy made with value 10 with a different address, and a is pointing here because we have a here, right? Here this is the same a and a will point to 10. Let's say I'll do this. So the exact copy of x is made and passed to the function. So whatever modification you do in this function is not applied here. It will only be modified in the function scope, right? Now let's see what if I wanted to modify x in this function itself. Let's see how we can do that. I'll create a new function multiply by 2 pointer. I'll take the same variable names, and this time just a little difference that I will take a pointer to an integer variable, right? Now my a is actually a pointer to an integer variable. What this means is when I try to pass x to this function, now we have a different function. Let's say we have a function multiply by 2 pointer of a star int. Now what happens in this case is your x what goes to a is the same. What I mean by that is x will actually point to here, right? Now let's see how this works. And again, to access the value of a pointer, you always have to use the dereference operator. A is equal to star a into 2. Let's try and run this multiply by 2 pointer. And again, since ax is an integer here, we cannot directly pass x here. Sorry, we cannot directly pass x here. It has to be a pointer. So to have the reference, we need to use ampersand, right? And then let's try printing the value of x here. Maybe we'll format it a bit, x, and then here we will have pointer x, right? Let's try and run this. if you see here, x is still 10 when we first called multiply. And in the second case, that is pointer x, the value has been modified to 20. Now, when we are calling a function without pointers or without references, the by default behavior of Go is that the function call is made via value, which is called as call by value, where an exact copy of the variable is made and then passed to the function, that is call by value. And in the case where we are passing explicit pointers to the function is called call by reference. Call by value and call by reference are two very important concepts of Go, because there are different data types that follow different patterns. For example, when we look at structs in the future videos, by default structs are copied and then passed on to a function. But whereas slices, they are also copied, but only headers are copied. They are actually referenced. What do I mean by that? I'll explain in a while. But for now, please make a note of this, that call by value and call by reference, what their difference is and how they are actually implemented. Right? Now in call by reference, your x is actually passed on to the function, the actual reference. So any modifications you make via call by reference is persistent. Right? Now let's see how Go passes different data types to different functions as call by value or call by reference. Let's clear this out. Okay, let's clear this out as well. So you saw how integers are handled via pointers in Go, right? Now similarly, we'll see all the function calls are made as call by values. Now there is a little difference how slices work. Let's see how arrays and slices differ when passed to a function. Let's say there is modify function which takes in an array. Let's say I'll call it list. It has three elements and integer type. It is not returning anything. It will just modify one of the elements. Let's say I'll modify the first value to be 500. Now I will initialize my array. For now, I'll take list here also equal to an array of size 3, and I'll give the value of 10, 20 and 30. Right? And I will call the modify function with list and print out the list. I'll print out the list before also to see if it is actually modified or not. Let's run the program. If you see here, we are actually modifying the list. We can maybe print it out here also so that we know if it is getting modified or not. Right? Go run pointers.go. Yeah, if you see here, this was the initial call, then this is inside the function, and this is again back in the main function. Inside the function, it is modified because just like I told before, right? Arrays are also passed as values. So inside the function, it will change, but as soon as it is returned, it does not change because there is no reference to the original array, right? Now let's say instead of array, we have a slice. Let's see what happens in this case. In this case, if you see, the slice has been modified, right? 500, and even outside the main function it is 500. That is because slices are also passed as copies or call by values, but the slice, there is a slice pointer that is maintained in memory for the length, capacity and the pointer. So those things are always stored when passing out a slice. Now let's say I have a slice 10, 20 and 30, and this is my list. Right? Now when the function is invoked, a copy of this is made, right? 10, 20, 30. But the function actually receives a pointer to its header, 10, 20, 30, and the length and capacity pointers are also given to the function. When we modify the value, since it's the header is a pointer reference, the value once it's modified here, let's say it is 100, the value here is also modified. But let's say you're trying to entirely reassign. What I mean by that is, let's say I'm adding one value to 20, 30 and 40. Since the length, since the length and the header is also shared, this particular addition of an element to the slice will not work. The inside values can change, but the underlying slice will not change. That's the difference in array and a slice, right? Now let's see that in code. Let's say list is equal to append list comma 1000. Let's see what happens. Maybe I'll print inside function and now run the program. Inside function, the slice has been modified with a new element, but the original slice, only the value has changed, but the length of slice remains same. So that's the key difference between a slice and an array when you pass it as a value. When you pass it as a reference, it's the same behavior for all the data types. Whatever you modify in the function as a reference will be carried out or persisted in the main function or the caller function as well. So that was all about pointers in Go. I hope you enjoyed the video. On that note, this is Cron Coders signing off. See you on the next one.